graders. I hope you all had a great weekend. Welcome to our Monday, May 4th video. First off, I want to say before I forget, happy birthday to Kenna Remley's birthday was yesterday, and Megan Storbachen's birthday is today. So happy birthday, ladies. I hope you have a great day. Kenna, I hope you had a great birthday, and Megan, I hope you have a good day today. So what I was thinking kind of last week, I'm like, gosh, you know, it would be really fun to do something fun and exciting kind of these last couple of weeks of our science unit, since it's the end of the year and we're kind of been doing this online learning for so long, and I just wanted to do something fun. So I decided that since I have so many kids who ask us to do a science fair, I thought I could do a virtual, kind of like a science fair. You don't really have to do anything big and crazy like a science fair, but it's going to be a chance for you to do any science experiment you want to do, and we're going to kind of pretend it's a science fair. So you can go as big as you want, you can go as crazy as you want, you could make a poster like me, you could do the experiment however you want to do it. You could take a video of it, you could make a PowerPoint with pictures, you can do whatever you want. Or you could just write me a paragraph. You could just fill out the Word document that I have connected to this assignment here, and you can just fill that out and tell me what happened in your experiment. That's all you need to do. Now here's the best part, is I'm going to do an experiment over the next 4 days, and they're super easy at-home experiments that you can do too, that if you don't want to think of your own crazy experiment to do, you could do one of these super easy experiments and it would count as your science fair project as well. So very simple, very easy, or you can make it as extravagant as you want. That's the great thing about our online learning right now, is everybody can kind of do what fits them best. So what I'm going to do is I'm going to show you my first experiment for today, and kind of what you need to do overall for an experiment, any experiment you want to do. So what I'm going to do is I'm going to do an experiment on evaporation. And we kind of just talked about evaporation when we talked about the water cycle, so you kind of have an idea what it is, right? And so the question I have is, which will evaporate faster, water in a cool or warm location? So what I did was, if you look at the experiment here, is I took 2 containers and I put 1/4 cup of water in each one. So I made sure that I measured out 1/4 cup in each one so that each had the exact amount. So that way there's no differences. The control is the same. That would be an independent variable, is that they are both have 1/4 cup in it, right? And so I'm going to put 1 in our cool basement here, and I'm going to leave it sit here, and I'm going to test in time and see how long it takes for the water to evaporate. And then I'm also going to take the other cup and I'm going to put it upstairs in the windowsill, and I'm going to see how long it takes that water to evaporate. So my question is, which one's going to evaporate faster? And so of course I have to do a hypothesis, right? It's an educated guess as to what you think is going to happen. Now remember, when we did this at the beginning of the year, we said I think blank because blank. You kind of have to explain your thinking. So for example, if I were to be doing this one, I would say I think the cup that's sitting on the windowsill in the warmer temperature is going to evaporate faster because more thermal energy will be added, which will cause the process to go faster. And so that's what I would put for my hypothesis. So I said what I think is going to happen, and then I also wrote why I think that is going to happen. So question, hypothesis, experiment. If you wanted to do this experiment for your science project, you could copy exactly down what I have right here, and that it would be easy to do. Okay. Results. What I would have to do is I would measure the time it takes. So I'm going to set 1 cup up. As soon as I'm done here, I'm going to set 1 cup up down in the basement, 1 cup up in the windowsill. It'll be the same time, and then I'm just going to check on it periodically and see which one evaporates faster. Then my conclusion, this is what I'm going to do, is next Monday I'm going to do my video is going to be the conclusion of all my experiments that I show you throughout the week. So I'm going to show you 4 different ones, and then on Friday or Monday when we come back, I'm going to show you what I got from my answers. And Friday, let's see, Friday will be the day that your experiments are due. So you have to have them submitted by Friday at midnight. And then Monday is when I'll show you. I was just trying to think of when I want to do all that. Yeah, so we'll do Friday at midnight is when your experiment is due to be sent to me. But make sure you check out all 4 videos from this week so that way you can see what your options are. Okay? So conclusion, you would put, I found that blah, 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 blah. So I'm going to find out what happened with these 2 and figure out, you know, which one evaporated faster. One thing I want you to include in your conclusion is I want you to tell me what the control is and the independent and dependent variable. So for example, the control in here, the control is something that always stays the same. So in this experiment, I have the same size cups. I have the same room temperature water. I have 1/4 cup of water in each one that I measured out with a measuring spoon. And so that's all the same. Okay, the independent variable is going to be one of these cups is going to be in the basement in a cooler temperature. The other cup is going to be on a windowsill in a warmer temperature. And so those are the independent variables, okay? Those are the things that are independent to those tests. The dependent variable is what's going to happen because of those independent variables. So which one is going to evaporate faster because of where it is located? That's what we're trying to find out. So hopefully this helps you. Gives you an idea of what you need to do. What I did is at the bottom of this assignment, there's a Word document that says Science Fair Project. And I have an outline like this where I have the question, hypothesis, experiment, result, and conclusion. And all you have to do is fill that out. You can send it back to me, and you're done. If you wanted to do your own thing like this, like a PowerPoint, or you want to do a poster, or you want to do a video showing this information, you don't even have to submit the Word document. You just have to submit something to me showing me that you did it. It's kind of like our Earth Day project, but with a science fair project. So you can do, if you want to take the easy route and go through and do this, because sometimes that's just what we need to do right now, is the easiest, right? Whatever is the most simple, easy for you, that is just fine. But if you feel like going above and beyond, this is great too. Okay, if you have any questions, send me a message and let me know. This is due Friday, and this is just one of the examples of what you can do. I will have 3 more videos over the next 3 days of things that you could do if you wanted, and then also if you wanted to look up your own experiment, you can do that too. It can be anything you want at all. You just need to answer these different parts of the scientific method. Have a good day, everybody.